Since there's a time constraint, I do not give an introduction to the company. If you want to know more about the company, please visit us at booth B60 back there, or visit us at the webpage hexagongroup.com, or tomorrow morning at 10:40 there's another presentation where you can hear more about the company and our general product portfolio. We from Hexagon, we believe in the future of the hydrogen mobility. However, we know that there are some hurdles to take. And one of the hurdles is definitely the cost. If we look at the cost for the vehicle user, then we can state that it is built up of three major blocks. We have the cost of production, we have the cost of distribution, and we have the cost of the refueling. This gives the total cost. This is only the cost, don't confuse it with the price. Here in Germany right now, the price is kept artificially at €9.50 per kilogram. If you make the backward calculation, what does it mean in terms of cost? To be profitable, you should have a cost maybe of 7.50. However, in the area of buses, maybe you should even go lower. There are different ways of distributing hydrogen from the production site to the refueling station. Established and widespread ways of hydrogen distribution are per compressed form or in cryogenic tankers as liquid. Then there are other alternatives like pipeline, or you can have it chemically bound to either a liquid or a solid carrier. And then there are others. Of course, we from Hexagon, we design and manufacture composite high-pressure Type 4 vessels and systems, and also distribution systems. So therefore, we have a high interest in improving our competitiveness of the compressed hydrogen, because all these technologies, they compete with each other. Therefore, this presentation focuses on the road distribution of compressed hydrogen. Compressed hydrogen has been distributed for decades. It's not something that we have invented. And it is distributed in the industrial gas segment. There's a huge demand for hydrogen in the industrial gas area. And predominantly Type 1 steel tube trailers are used. And in 2014, however, we, together with a partner company, we were pioneers in bringing the first Type 4 full composite lightweight distribution system into the market. Since then, 30 of these X-Store systems, that is our brand that we use, are in operation for compressed hydrogen. If you compare the two technologies, then there are significant differences. Steel has usually lower operating pressure, 200, maybe 250 bar. It is heavy. It has a limited payload because they reach immediately the maximum gross vehicle weight. Usually they are also available just in one length, so there's no flexibility in sizes. There are no short tube trailers available. But the big advantage is they have low purchasing price. But given the low payload, they have high operational costs because they have to drive a lot to deliver the same amount of gas. To the opposite, our X-Store modules in full composite construction, they are lightweight, they are available in different pressure levels, 300, 500 bar, maybe in the future even higher pressure levels. Due to the lightweight, we can carry much more gas. Today our flagship carries 1,100 kilograms of hydrogen. They are flexible in sizes, but the disadvantage is they have high purchasing price. But given the high payload, they have much lower operational costs. Now, with this I built a case study. And the goal of the case study is to make a TCO calculation, so total cost of ownership, and also calculation of the cost of the distributed hydrogen. And I also compare a composite with a steel system. If you want to do a TCO calculation of a distribution system, you have to take into consideration three components, major components. You have the tractor that pulls the whole thing, you have the distribution system itself, and then you have the trailer chassis that is underneath. Sometimes the distribution system and the chassis, they form one integral unit. This is in Europe called a battery vehicle. And the opposite is the containerized solution. You need the following input for a thorough and complete total cost of ownership calculation. You have the equipment-related input, which is the price, of course. You need the depreciation time of the equipment, which is different from country to country. And then you have all the OPEX-related input, like driver's cost, fuel cost, wear and tear, repairs, insurance, and also very important, mandatory periodical inspection. This is very important for the distribution system itself. And then for any specific case, you need general input data for your calculation. For example, you need the distance between the production site and the refueling station. You need the demand at the refueling station. You also need a discount rate, because for the TCO, we use a net present value calculation. The project horizon is also important, how many years you are looking at. And then there are some others, like the concept of the refueling station, the average velocity, and so on and so on. So with this, you can build a TCO calculation. Real life usually looks pretty complex. In the future, we assume that you will have centralized production hubs. And from those production hubs, then several refueling stations are served. However, they all differ in distance and demand and even in concept. They can be private or they can be public. This is too complex to build a case study right now in this presentation. Therefore, I made a simplified base case. We have the production hub, we look at one refueling station. And I choose these average values, 100 kilometers of distance and 500 kilograms in demand. The 500 kilograms correspond to roughly 100 cars per day, passenger cars. Or if you think of a bus station, we are talking about 20 to 25 buses per day. So it's pretty realistic. And then we have the general input data for this base case. 30 years project lifetime, 10 years of depreciation, then 7% for the discount rate. And then we use also, for the sake of simplicity, tractor cost of 1.40 euros per kilometer, and for the chassis also 0.1, that gives a total of 1.5. This is a worst case at the same time. Why is it a worst case? Because here you have a dedicated tractor for the distribution system, which normally you don't have. In reality, you usually have tractors shared by different distribution systems. And then we have the equipment-related input, and here I compare the two systems, the X-Store, the composite system, and the steel system. So they differ here in the price, as you can see. So 600,000 on one side, 200,000 on the other side. We have 900 kilograms of usable hydrogen. If we assume that they return pretty empty, 10 bar inside, it's an assumption. And we have 300 kilos on the other side. And then we also fairly estimated the inspection and maintenance costs that we have over the lifetime. And this is now the result of the total cost of ownership. So the green curve is the total cost of ownership at any year within 30 years of the composite system. And the black one is for the steel. So you see a huge gap. And of course, the longer the time horizon is the bigger gets the gap. or the advantage of the composite system. This is now the graph that shows you the cost of distributed hydrogen. Green is for composite, black is for steel. We have in the first 10 years a higher value because we still have the depreciation of the system. After 10 years, the depreciation is taken out, and then you only have the pure operational costs. Therefore, the price or the cost falls down. The thin line is the average at any given year. So you see the huge difference between composite and steel. So this is now one case study, the base case. What I did now was I took this model and I changed values. So I created different data sets. And I changed those values that have probably the biggest impact here, which is the distance and the demand at the refueling station. And then I created a graph. And this is the graph for the composite distribution system. And it follows a certain logic. Means the more the higher the demand is, the lower the cost of hydrogen gets. And the more you have to drive, the higher the cost gets. The red circle gives you the value for the base case. In this case, 0.76 euros per kilogram of transported hydrogen for this specific case during the depreciation phase. This is the graph for the steel unit. You see higher values. Also in the red circle, the value for the base case, 1.13, roughly 50% above the composite value. And finally, I made a direct comparison between steel and composite. Green is the composite distribution system and gray is the steel one. And with only very few exceptions, that is with extreme low demand, the composite wins over the steel system in total cost of ownership and cost per distributed kilogram of hydrogen. I conclude my presentation now with several statements. Composite X-Store Type 4 distribution systems are reliable and proven in the field. They considerably reduce TCO and cost of transported hydrogen. They contribute to the success of compressed hydrogen. And a general observation, the cost of delivered hydrogen comes down with higher demand at the station. And to give you a level, we can easily reach 0.5 euro per kilograms or even below that if we only had demand that is high enough at the station. Last sentence, what does it mean? We just need more vehicles on the road. Thank you very much.
Thank you very much, Hartmut Fehrenbach. Are there any questions from the audience? No? Yes?
Thank you. I didn't get completely the cost you presented, the 0.8 or 0.5 euros per kilogram of hydrogen was only for the distribution, or?
This is correct. This is only for the distribution. Nothing to do with production or refueling. You have to add the other two cost blocks.
Do you have any information about this? I mean, it's not your business, but...
Exactly, this is not your business, and I would not want to lean out of the window too much. We do not
but
have...
a bit, maybe, a bit. You may lean out of the window. Can any figure, a rough figure for...
Very hard for me to give you a figure.
Any further questions?
Maybe I can give you a figure. I mean, we are working on a project, I don't know, tell you the name, where we define a target. And the target that we would like to see is 3 euro for the production, 1 euro for the distribution, 1 euro for refueling. Whether we can achieve this, I don't know. For the distribution, it looks very positive.
Thank you. Further questions from the audience? Okay, then I have one. You've mentioned for the X-Store the payload of 1,100 kilogram. What do you predict for the future for the transportation amount of hydrogen in trucks?
Yes, correct. So the flagship today carries 1,100 kilograms nominal payload. There are initiatives now around to change the standards, and If they come reality, then maybe from 2021, the latest 2023 on, we have new standards in place for the distribution of hydrogen, and with the new standards we might reach a payload of 1,500 kilograms per truck.
Thank you very much. Further questions from the audience? Otherwise, we will close this discussion. Thank you very much again. If you have further
topics
to talk about, please go to booth B60 to discuss the topics.